Hello everyone, in this video we will see the equation of hyperbola in complex plane. Equation of hyperbola in complex plane. This equation modulus of z minus z1 minus modulus of z minus z2, that is equal to k, represent a hyperbola if modulus of z1 minus z2 is greater than k. See, in ellipse, what happens? Modulus of z1 minus z2 plus modulus of z minus z2, that is equal to k ellipse. If modulus of z1 minus z2 is less than k, correct? So here plus, here minus, okay? So modulus of z minus z1 plus modulus of z minus z2, that is equal to k, plus is there. Represent an ellipse if modulus of z1 minus z2 is less than k, and z1 and z2 are foci. z1 and z2 are foci of the ellipse. And here modulus of z1 minus z2 minus modulus of z minus z2 equal to k, represent an hyperbola. Here minus, there plus, correct? If modulus of z1 minus z2 is greater than k, here greater than k, here less than k, correct? And if it is equal to k, then it represents a straight line which is passing through the z1 and z2, and z is not lying between z1 and z2. But here, if modulus of z1 minus z2 equal to k, then we are lying, z is lying between z1 and z2 on the line which is passing through the z1 and z2, but lying between z1 and z2, because this distance is modulus of z1 minus z2, this distance is modulus of, and sum of these two distances is modulus of z1 minus z2. This modulus is this whole distance, this modulus is this one plus this modulus is this one, sum of these two is z1 minus z2, and that is equal to k. At that time this not represent an ellipse, rather it represent a straight line, and z is lying between z1 and z2, correct? But here if modulus of z1 minus z2 equal to k, then again it does not represent an hyperbola, rather it represent a straight line, but z is lying on the lines which is passing through the z1 and z2, and z does not lie between z1 and z2. And if z1 minus z2 is less than k here, then this locus, there is no such a locus of z exists. And here if modulus of z1 minus z2 is greater than k, then no locus of z satisfied this, correct? So this is the concept. Now the question is that if the equation of hyperbola is given in complex plane, then how to convert it into the rectangular form? Okay, how to convert it into the rectangular form? See, first question is, first one is modulus of z plus 2 iota minus modulus of z minus 2 iota, and that is equal to 4. So see, this is minus 2 iota, that is 0 comma 2 in coordinate plane. This is 0 comma minus 2, this is 0 comma minus 2, and this is 0 comma 2. These are the foci if it represents a hyperbola, but the distance between the foci is 4, and that cannot be equal to 4 over here. So therefore this not a hyperbola, rather it is a straight line, it is a straight line, and a straight line like that, this is minus, straight line like that, this is 0 comma minus 2, this is 0 comma 2, and here z is lying, correct? So distance of this z from this point minus distance of this z from this line is equal to distance between these two, that is 4. So therefore this is a straight line at this time. Now coming to the question number 2. Question number 2 is like that. If z plus 2 iota minus z minus 2 iota, that is equal to 8. If it is 8. So at this time the distance between these two 0 comma minus 2 and 0 comma minus 2 is 4 and 4 is less than 8. So therefore no such locus exists. No such locus exists. Second question is also over. And if suppose that, third one, if suppose that z plus 2 iota minus z minus 2 iota equal to 2, then this definitely represent hyperbola. Here z1 is 0 comma minus 2, z2 is 0 comma 2, modulus of z1 minus z2 is 4, which is greater than 2, therefore hyperbola. It represent a hyperbola. Okay, foci is z1 and z2 and length of transverse axis is 2. Length of transverse axis is 2. Now as this is a conjugate hyperbola because the foci are lying on y-axis, therefore it is a conjugate hyperbola. So therefore its equation something like that, x square by a square minus y square by b square, that is equal to minus 1, correct? So you have to convert this equation into coordinate form, that is x square by a square minus y square by b square, that is equal to minus 1. Now b can be find out, no? Length of transverse axis, that is 2b is equal to 2. So this is b is equal to 1 directly, correct? 2b is equal to 2. So therefore b is equal to 1. And the distance between the foci, that is 2BE is 4. This distance between the foci is 4. So therefore I can find out E, 4 by 2B, that is 4 by 2, that is equal to 2. Therefore E square equal to 4. E square means B square plus A square upon B square equal to 4. So B is 1, B square is also 1, plus A square by 1 equal to 4. This gives A square equal to 3. And therefore your hyperbola is x square by 3 minus ka y square by 1, that is equal to minus 1 because it is a conjugate hyperbola. So we have find out the equation of hyperbola in coordinate form. This is the equation of hyperbola in a complex form. First you should know that this represent actually the hyperbola with the foci at 0 comma minus 2 and 0 comma 2, that is the foci are lying on the y-axis, therefore it is a conjugate hyperbola. Its equation must be of this form, x square by a square minus y square by b square, that is equal to minus 1. Why it is an hyperbola? Because this condition is satisfied, the distance between the foci is greater than this 2, okay, that is the length of the major axis. Okay, fine. Now come to the hyperbola equation. Last example over here. What is that last example? The last example is, see, if I say that modulus of x plus 3 minus modulus of x minus 3, that is equal to 2. So here foci is at minus 3 comma 0 and at 3 comma 0. So modulus of z1 minus z2 is 6, which is greater than 2, therefore hyperbola. Not conjugate hyperbola, this is hyperbola. And therefore 2a is equal to 2, this gives a is equal to 1. And 2ae is equal to the distance between the foci, that is 6. So therefore e is equal to 6 by 2a, that is equal to 2, 6 by 2, that is equal to 3. Therefore e square equal to 9, therefore a square plus ka b square by a square equal to 9. A square is how much? A square is 1. So this gives 1 plus b square equal to 9, b square equal to 8. Therefore your hyperbola is x square by a square, that is 1, minus y square by b square, that is 8, and here that is equal to 1. Okay, because the hyperbola equation is x square by a square minus y square by b square, that is equal to 1. Conjugate hyperbola equation is x square minus y square by b square, that is equal to minus 1. This is conjugate hyperbola. This is your hyperbola. Hyperbola where the foci lies on the transverse axis, that is x-axis, and the conjugate hyperbola where the foci lie on y-axis. Correct? So this is all about the equation of hyperbola in argon. plane.